All right, let's get started. Thanks for joining us here today, folks. Welcome to BRK135, from dev to prod, how to build agentic memory with Azure Cosmos DB. I'm James Codella. I'm an AI product lead for Cosmos DB. And today we're going to talk a little bit about, obviously, agentic memories, but we'll go through a process of what are memories. We'll talk about why Cosmos DB is a great database for agentic memories. We'll walk through some design patterns. And then we'll hear from our friends at 𝗦𝗲𝗀𝗃𝗀𝗃 and Walmart Chile about how they built their agentic platforms on Azure using Azure Cosmos DB for storing short-term and long-term memories. So let's get started. I'll talk real briefly about Cosmos DB for AI, why it's particularly well suited for agentic memories. We have some exciting announcements with regards to search and AI for Cosmos DB, so we'll cover those real quickly. And then we'll go through some design patterns for how you're going to do this in Cosmos DB. And I have some resources for some GitHub repositories that have code samples and accelerators to get you started building your applications. And then, of course, we'll hear from 𝗦𝗲𝗀𝗃𝗀𝗃 and Walmart Chile. So let's start with the question. What does a database need for agentic memories? And also, why do thousands of customers build their applications for agentic memories in Cosmos DB today? Well, you may want flexible retrieval methods, right? And in Cosmos DB, you're able to write NoSQL queries, right? So it's a SQL-like syntax, and you can execute semantic search, vector search, full text search, and combined and hybrid search together, all in your core data stored in Cosmos. Multi-tenancy is critical, right? You need to isolate memories by agents, by threads, by users, by tenants in a multi-tenant application. And Cosmos DB is built for multi-tenancy by design, offering you logical and physical partitioning for multi-tenancy. You need flexible data models. As your applications evolve, your short-term memories and your long-term memories may have different structure. Cosmos DB, being a NoSQL database, is of course schema-free. All your documents are just stored, they're just JSON documents, right? You can store your vector embeddings for semantic search in the document itself alongside your other data. Cost effectiveness is key here. So thanks to the Microsoft DiskANN vector indexing algorithm, executing vector search or semantic search on Cosmos DB is cheaper than a cup of coffee. If you use Cosmos DB serverless, you can insert 100,000 vectors and do 100,000 vector searches for under $3. It's incredibly cost-effective to get started with your agentic applications. It's also extremely fast, right? Low latency search. You can scale Cosmos DB using our autoscale capability to contain more than 1 billion vectors across your partition and execute an end-to-end vector search in under 100 milliseconds searching on that graph index. Scalability is also critical, right? Cosmos DB is known for its elasticity. It automatically shards and partitions your data for you and can grow out as your data size grows or as your throughput needs increase. And finally, enterprise readiness, right? Cosmos DB is configurable up to 5 nines of availability, plus geo-replication and multi-region reads and writes, so your applications stay fast and responsive no matter where your users are. And of course, the probably largest agentic memory scenario today on Cosmos DB is run by OpenAI, right? ChatGPT has over 800 million monthly active users, and more than 50 different workloads are kept on Cosmos DB today, including chat history and agentic memories, right? So if Cosmos DB is pretty scalable for OpenAI, it's probably pretty scalable and pretty elastic for your use case as well. And this unlocks a whole host of scenarios, right? So starting from the left, you're able to keep your operational and vector data all in one place. So your memories, your back and forths between your agent and your user, or two agents, or agents and a tool, or an MCP server, this data can be stored in Cosmos DB without the need to ETL it to a search engine or a specialized vector database. And this unlocks additional sort of scenarios like RAG for grounding your models, storing and retrieving conversational history for thread persistence, semantic caching, where you can store responses from large language models on Cosmos DB and perform semantic search to bring them back. So it saves on token consumption and latency of calling your large language models. And then finally, for all of these scenarios for agents, like Cosmos DB is really a critical component here, right? Storing short-term and long-term memories, storing those transactions. You know, if you use a service like or a framework like LangChain or LangGraph, you can store checkpoints of your agentic applications in Cosmos DB as well. So those are some of the use cases for Cosmos. So what's new at Ignite, particularly for AI and search? So we have new features in vector search for Cosmos DB. Starting from the left, we're enabling the float16 data type for your vector embeddings. Most vector embeddings are float32s. You're able actually now to cast them as float16s in Cosmos DB. This reduces the storage footprint of your vectors by up to 50% while still keeping recall high. We also have multiple performance improvements that have rolled out and are continuing to roll out over the next several months that will give faster vector indexing and search up to 2 to 3x performance increasing for inserting large-scale workloads. We're excited to announce a private preview of Semantic Re-Ranker, where you can use an AI model to increase the relevancy of your semantic searches, and of course, flexibility in modifying your vector indexes as well. For full-text search, we have multiple new features. We're bringing fuzzy search from public preview to general availability. This allows you to have approximate and typo-resilient text searches on your text data, like your agentic memories. We're adding support for new languages, including Italian, Portuguese, and Brazilian Portuguese into our full-text index. We have performance improvements for indexing on full-text data and for BM25 scoring, so you can look up statistical measures of your text searches even faster. And we're also enabling you to choose custom stop word lists and custom stop words that gives you flexibility for faster search or more accurate text search as well. Okay, so let's get into some quick primer definitions here for what we're going to talk about, right? So if you think about generative AI application, you can sort of compartmentalize it into 3 areas. There's the prompt, which is the input to your model. Everything goes in there. Your memories, your results from RAG, anything you want the model to process goes into your prompt. There's the model itself, and you can pick your model like your GPT-5s of the world, GPT-4os, et cetera. And you can tune hyperparameters of that model, like the temperature. Then you have your output. So that's what comes out of your model, right? So what we're going to do is we're going to hyper-focus today and talk about the prompt. And of course, the prompt consists of multiple parts, everything from skills to knowledge from RAG, and then of course the memories, which is going to be the highlight of what we talk about here today. So what are memories, right? Wikipedia has this nice, succinct sort of definition here about writing, storing, and retrieving memories. And at each one of those steps, there's decisions that you have to make, right? What do I want to store as a memory? How am I going to store it? When do I want to store or persist this in a database? What happens if I need to update a memory, right? And every step, not only are there questions, but there's some processing work that needs to be done as well, some asynchronous processing tasks that has to be done, right? And there's different types of agentic memories, right? In brief, there's 2 broad categories. Short-term memories, so these are things like chat history or working memory. These are the things that you want to keep alive in your application and in your session, so you can feed it back to the large language model or your agent when you need it, right? All these large language models are stateless. They don't know, one input from the next. The way that you simulate statefulness of these large language models is you feed in history or memory from previous interactions to really ground the model in that conversation context. So short-term, you have that working memory. Long-term memory are these memories that are either aggregated or processed, right? So imagine you're using ChatGPT and you've been, like me, talking on a single thread for months about one topic on ChatGPT, right? That's a huge amount of data that needs to be stored. And it may be more fruitful to actually summarize that really long thread or bits of that thread to make it more searchable and higher utility for your large language model to use for downstream tasks. So we'll cover briefly some design patterns for memories in Cosmos DB. We'll start with partitioning. So how do you configure your partition key in Cosmos DB for memories in different scenarios? Indexing, we'll talk real quickly about some data models and simple retrieval patterns, and then some tips for processing as well. So in Cosmos DB, we automatically shard your data. You basically give us a partition key, so it's a hint for how Cosmos DB should partition your data. And there's multiple different ways of doing this. There's generally 3 recommendations for how you choose a partition key for your agentic memories. You can start off by having a thread ID. So you can imagine a thread is like a session, like a chat session, say with ChatGPT. And you can have a unique GUID for that session, so you can keep all that data in that logical partition in Cosmos. Or you can have a hierarchical partition key, where maybe you want to have a user ID, and that user can have multiple threads, like what happens in ChatGPT. If you have a multi-tenant application, you can even extend that to a 3rd level of the hierarchy. So you can have a tenant ID, a user ID, and thread ID to really keep your memories isolated, not just by users, but then also tenants. And this allows you to spread out your memory insertions by logical partitions. So you can insert data faster and more efficiently into Cosmos DB. But also when you search later on, whether you're doing a simple query, like give me the last 10 things we talked about, or you're doing a semantic search, it allows you to focus your search for lower latency and lower cost searches by using that isolation. We have multiple types of vector indices in Cosmos DB as well. Quantized flat is essentially a compressed version that does a brute force search, and it's good for relatively small scale use cases. For anything larger than about 50,000 vectors or so, you'll want to use Microsoft DiskANN Vector Index, which is our world-class vector index that's used widely in Microsoft itself. And then, of course, we have a sharded version of DiskANN, which allows you to basically create unique vector indices per tenant based on your partition key, right? So if I want to isolate my vector search for even faster and more accurate performance, I can do this at a tenant or user level as well. I mentioned that we have a full text index for full text search as well, and defining this in Cosmos DB is really actually quite simple, just as defining any sort of indexing policy in Cosmos today. And this opens the door to fuzzy matching, to text-based search and stemming, and also to BM25 scoring, which takes into account the frequency of your search terms in the memories themselves. Now, there's a lot of different ways of storing agentic memories in a database. And again, the flexibility of Cosmos DB allows you to iterate on this sort of data model. But this is the one that we typically recommend, at least to get you started, right? There's a data model where you have an ID, maybe it's a tenant ID in this case. You have a type that describes the type of memory. So in this example here, I call it a turn, right? A turn is basically a single back and forth between a user and an agent and an agent, or an agent and a tool, like an MCP server, right? So I'm able to store the essential metadata about that in one JSON document. And then I basically just have an array of back and forths from my user and my agent here. So here I have an example of what that looks like, additional metadata. And you can see at the bottom that I've actually created a vector embedding in this example of the back and forth of the turn. So that way I can search for it later on if I want to recall some useful information, right? This is really great. Like, it allows you a decent level of granularity. It supports multimodal retrieval. And Cosmos DB also has a time to live feature, right? So you can set this, if you don't want to keep memory stored in Cosmos DB longer than 3 months, 6 months, 1 year, you can actually set the TTL so Cosmos DB will automatically delete those memories for you if they're no longer relevant. There's many different types of long-term memory, and I have some resources for you to see everything from summarizations to key relationship extraction and other information. In this example here, we have a summary as a long-term memory. So essentially, you can think about, I have a very long thread, conversational thread, all these data items that are back and forths between an agent and the user. I'm able to summarize those and store the summary and key facts in a single document. So this is great if I want to search across different threads and I want my agent to have the contextual information from those threads. I can do it using a semantic search just on the summaries themselves. And this reduces my token usage. It's lower latency because there's fewer pieces of information actually going into the large language model. And of course, there's considerations that you have to use when you summarize any data. You may lose some detail. The model that you use, there's a lot of dependency in the model you use for an accurate summarization. You have to worry about, you have to think through your orchestration patterns for how you update summaries as threads continue. And then the other important thing to know is, like, this may be less suited for sort of replay or auditing, right? So if you need really specific information for large language models, or you need to keep records for auditing purposes, like in highly regulated industries, you don't necessarily want to delete individual memories. You still want to keep those around, but you can still use the summaries as at least a good guide for your large language models. And then, of course, for these data models, there's multiple different retrieval patterns, right? So Cosmos DB has a SQL-like query language that allows you to really easily get, say, the most recent conversations, where I could just choose the most recent conversations, order by the timestamp, and then isolate based on the thread. So I'm getting the relevant information or memory for that thread. Semantic search is also equally as easy to write. There's just a simple order by vector distance query here that then will leverage the vector indexing policy that you use. For full text search, you can take advantage of full text contains and other sort of operations to use the full text index to find specialized keywords or phrases in the data. Hybrid search combines the best of both worlds for vector search and the statistical measures of your phrases, found in the memories themselves to give you even higher relevancy. And of course, as with any of the queries that I showed, you can add where clause filters however you want. And so a simple example of isolating for a particular tenant, you would just add a where clause isolating to a particular tenant value or a set or subset of tenants. Now for storage and retrieval, there's some general tips. You want to keep active memories in session, and you want to be able to persist them and have return in a database. So you need to keep those active memories live in RAM because you want to feed them to your LLM quickly without any latency. But after one back and forth between, say, a user and an agent, or an agent and another agent, you want to store those in a persistence data layer like Cosmos DB, right? If I'm a user and I'm talking with ChatGPT and I accidentally close my Edge browser, or something happens and the application crashes, when I start it up again, I want it to start right from where we left off. So it's important to think through what are the storage patterns for the persistency and resilience needs that my application has. Similarly, for summarizing threads, it's really important to sort of label these memory types, like what's a summary and what's sort of a raw piece of data or raw memory. That way you're retrieving the right information for your use case. You can oftentimes be very efficient and use small language models or mini or nano versions of, say, GPT-5 to make it really efficient and fast for generating these memories. And of course, you want to offload this processing to some workers, right? So this is a great use case for something like Azure Functions or Azure Container Apps or Logic Apps, where you can use this as the compute layer for orchestrating summarization of your memories or organization or deletion of stale memories. Speaking of which, there's also methods that you can use for deprioritizing older memories based on the time, and you can do this by giving specific prompts to your large language models. For deleting memories, I mentioned that there's time to live built into Cosmos DB, but you can also use metadata to sort of classify or maintain longevity, then use an orchestrator to delete these memories. And I know I don't have specific examples here, but I do have some great resources on GitHub that actually talk about these things in depth with code samples, starting with a really simple sample library called Cosmic Memory. This is basically a really simple Python framework for storing memories in RAM and then persisting them in Cosmos DB for advanced semantic search and retrieval using Microsoft Foundry OpenAI models. And then, of course, if you joined us on Monday for our workshop, then this is no news for you. But we also have a hands-on workshop for multi-agent memories that goes in depth in complex long-term memory creation and orchestration as well. So you can go check out the AKMS link there and a QR code to get you started. All right, so now let's move to production and see examples of agentic memories that are deployed in production today. And I'll hand it over to Derek from IntelliPeer. He's the VP of Product for AI and Data at IntelliPeer, and he's he's here to talk about the great platform that they've built using Cosmos DB as a persistence layer. Derek?
Excellent. Thank you, James. Good morning, everybody. So who's IntelliPeer and what do we do? So at IntelliPeer, we provide highly scalable digital and voice conversational AI solutions for our customers. And though our customers span enterprise and small and medium businesses, we're really highly focused on our small and medium business customers, our SMBs, who historically have not had access to solutions driven by AI for their customer experience. And so that's really our focus. We've been around for over 20 years, and we have over 300 employees. We're based in South Florida. So what are some of the benefits our customers see with our solutions? So using Azure Cosmos DB and Azure OpenAI, we're able to provide our customers with these measurable benefits. And these benefits can span the ability to automate over 20,000 interactions, 20,000 customer engagements in a very short period of time from initial deployment. We have customers that have collected over $6 million in overdue payments within 7 months. Customers that have seen a 7% increase in revenue because we help them book more appointments that they would not have been able to do otherwise. So how do we do this? Well, we built our AI framework, our agentic AI framework, on top of our very own carrier-grade voice network. And so what this does is it provides us really a true end-to-end, highly scalable conversational AI solution. So we not only provide the voice network, the Agentic AI framework on top of that, but we also have integration hub capabilities that we can integrate to over hundreds of different applications and data sources. And we also have a very robust smart analytics capability that allows us to analyze customer engagements across their life cycle. So let's dig into a little bit about how we've used Cosmos DB to meet our Agentic AI memory requirements. So we started this journey of adding AI to our capabilities about 3 years ago, and we had a number of requirements that we knew about. We knew we needed multi-tenancy, native observability. We knew we needed memory, though at that time we didn't call it short-term and long-term memory. We needed a way to evaluate the agents and so on and so forth. And so we started our journey using the Azure Foundry models for OpenAI, but we hosted the rest of the AI architecture, AI framework within our own data centers. And that was okay for a while, but what happened is we started experiencing some latency. And if you're familiar or know anything about the voice channel, latency is your enemy. You're doing everything you can to reduce latency, as you have to deal with latency from speech to text, at the inference layer, at the network layer, back text to speech, and so on. And so every little millisecond counts. At the same time, and more importantly, our data structure that was supporting our memories, we were seeing, first of all, we had to provision it for our largest enterprise customers at their peak. So that means 90% of the time, we weren't using the capacity that we reserved, that we provisioned. And we also would see, because we had both what we call short-term and long-term memory now in the same physical architecture, oftentimes the long-term memory needs would impact the short-term memory needs and so on. And so what we did was we migrated our AI platform into Azure at this time. And in doing so, we moved also our memory needs into Cosmos DB. And what we've seen is a 50% reduction in both the network latency and the data latency as well. And so that's obviously a very beneficial to the use cases in the solution that we provide. So let's talk a little bit about our short-term memory requirements. James talked a lot about short-term memory and how it's what's used during the conversation. The LLMs are stateless. They don't understand what they responded with previously or what was asked previously. And so we use so the short-term memory requirements is this idea of conversational context to persist that during the course of the interaction. What tools were used by the AI agent to fulfill the needs of the interaction throughout? What data was collected about the caller, about their account, about their appointment that's coming, about the pizza order that they wanted to make? And our agents are also self-auditing, so they're auditing their own performance as well as tracking business KPIs. And so all this, we knew we needed a short-term memory solution in Azure. And so why is Cosmos DB? Well, first, the high-speed read-writes, right? So the sub-10 millisecond ability for our agents to send and retrieve information, extremely important for all the reasons that I talked about earlier. Auto-scaling. We no longer have to provision all this capacity for 10% of the year. And we can scale up and down based on the needs, which also helps us control costs, right? So it allows us to serve these SMB customers that we're building the solutions for. The time to live, James talked about this a lot, the ability to automatically roll off short-term memory data so we can keep it clean and lean. We actually keep ours around for about 7 days or so for various reasons. One, if you're on a call and you're trying to order your pizza and you get cut off, you call back in, and our AI agents can actually pick up right where you left off, right, using the short-term memory to carry on the conversation. You don't have to start from scratch. And then we actually use the CDC capabilities to move our short-term memory, transform it in a pipeline, and move it to long-term memory where we can use it to improve future experiences. So all these things together provide this fast, scalable, self-maintaining memory layer for and driving really our AI agent capabilities. So long-term memory. we needed long-term memory to hold some agent status information. So is it published, is it available, and some basic configuration data. We also needed to hold personalization, right? So contact history information that can be used to personalize the experience that the AI agents can use the next time you call to really craft the experience based on your past history. Enterprise level data. So we actually use long-term memory like a knowledge base. So we knew we needed to do things like provide information like what promotions are running for the pizza, what are the office hours that I can schedule appointments, what are the parking requirements as I show up at my dentist, where can I park and not park. And so we treat long-term memory as a knowledge base. And finally, we know we wanted to aggregate all this data across all of our customers within a vertical and create some benchmarks and some KPIs that would benefit us and our customers alike. So why did Cosmos DB meet these needs? One, the ability to support these highly complex queries on this long-term memory. It allows us to partition that need from the short-term memory needs and run these queries that drive the intelligence of our AI agents without impacting the short-term memory and its performance as we experienced when we built this within our own data centers. The flexible storage patterns, right? We have JSON history conversation histories that are in JSON format and simple key value pairs for configuration data, all stored in the flexible Cosmos DB structures. I talked about how we use long-term memory to drive enterprise level data. So what pizza promotions are available. That's enabled by the vector store capabilities that James mentioned as well. So we knew that was one of our requirements, and that was a need that Cosmos DB suits us very well. And then offsite data replication, so we can ensure that this long-term data that we've collected is always available for us. And I just wanted to make note too that we're actually experimenting with Cosmos DB graphs. It gives us another way, some novel ways to look at data. It'll allow us to traverse the data in more of a time travel kind of way. So we're excited to continue to experiment with Cosmos DB and what it can do for our use cases. So as we pull all these pieces together, short-term memory, how do they work together? So our IntelliBear smart agents, which are our AI agents, consist of sub-agents. So as the interactions come in, the digital and voice, we have guardrails and controllers. The guardrails control the use of the data. Controllers is what and when to pull from long-term memory. And then we have our sub-agents that are basically swarming on this data and taking control as needed as the conversation progresses. And all during this time, they're reading and writing to our short-term memory for that contextual knowledge, for driving the experience during the course of the interaction. And then again, we use the CDC pipeline to take the short-term memory data, transform it into usable long-term memory, really to drive the future experience improvements. So I wanted to end today just with a short demo of what the short-term memory looks like in our platform and how we can use it for troubleshooting. So what we're looking at here is actually one of our agentic AI agents. These are actually a bunch of sub-agents that handle different parts of a scheduling activity. So this is our scheduling management agent. So you can see we have new patient intake, schedule, cancel, and so on and so forth. Each one of these has specific rules that it has to follow, specific tools that it has access to get and retrieve data, and so on. But what we can actually do is load some of our memories, short-term memories. Excuse me, we knew this would happen and timed out 1 second. All right, 1 moment, please. Let me just log this back in. All right. So what we can do is we actually use, because I said we actually keep our short-term memory around for a little bit, there's a few reasons. One, just to drive the experience, but two, we also use it to understand how our agents are performing across a conversation. And so what I can do is load one of my conversations that I just made earlier, load it in. And on the left-hand side, we actually see our short-term memory loaded. So it has the conversation, it has data that was collected, and it actually has where the agents were during the course of the interaction. And what I can do is actually walk through the conversation. And as I walk through the conversation, see how the different sub-agents took control, how they supported the intent of the caller, and understand where I might need to make improvements, where my agents performed well, and so on. And so I will just step through. I can see I'm asking about the appointment. It's confirming my birthday to authenticate me. It's all this stuff in the left-hand panel is all our short-term memory from Cosmos DB. I can move forward the conversation, and behind you can see I'm navigating through those different sub-agents as each one's taking control of the conversation, sharing context, and so on. It's confirming which date I want to reschedule my appointment. I pick a time. I say, yeah, that works perfectly. It's integrating to the backend system to reschedule that appointment accordingly, and then ends the call. And so that's how we use short-term memory, not only for the experience, but also for after the experience to understand how things are performing. So that's IntelliPeer's use of Cosmos DB for both short and long-term memory needs for our Agentic AI framework. Happy to take questions after the session, and thank you for your time. James, back to you.
Thanks, Derek. So that's really cool, right? You're keeping those short-term memories. You're using them to rehydrate the session, so it's giving context to the humans, right? When you relive that chat session, then you're using your long-term memories to rehydrate the LLM, so it's contextually grounded. Then you can use that data later on also to improve the application. So really cool stuff. Thanks a lot, Derek. Okay, now we have Felipe Morales coming from Walmart Chile to talk to us about their agentic platforms built on Cosmos DB. Hey, Felipe.
Thank you. Thank you, James, and good morning, everyone. So I don't think that I need to introduce Walmart, but I do think that I need to introduce Chile, right? So we're a small country, a long way away, right on the edge of the continent in South America. Let's think about Chile as the size of two average US states, so to think. But what we do share with Walmart, of course, is our purpose, and our purpose of basically putting the customer in the center and ensuring that they have a great experience shopping at Walmart. So I'm sorry, I'm Felipe Morales. I'm the head of data analytics at Walmart Chile, of course. So together we're going to go over a couple of solutions that we have created to make sure that we put AI in the hands of the customers. But for sure, one of the things that it's very crucial is to put strategy and in the center of this in the beginning. So to start, what does it mean for Walmart? It means to, as part of the Walmart history, it means to put new technologies to serve customers better. And this today means embracing AI, of course, and AI is here. It's not a fleeting trend, even though the market might be saying other things. So this is basically it's here to stay. And why is this? Because no other tech probably has more impact when we put it on the customer's hands, right? So just to go straight to the point, we're going to go over Líder AI, Carrito Listo, right? These are two AI assistants that are designed to transform our customer experience. Líder is basically the banner, right? It's the brand name for Walmart in Chile. So you're going to see it all over the place when we go over this. So what do they do and how do they operate? So they understand consumer pain points. So they understand their words in their needs in their own words. They operate 360, so accessible for any channels, either it's in the app, WhatsApp, the homepage, or even potentially in the physical stores. They recommend value-adding actions, so it's products or shopping carts, organize events, leveraging the loyalty program that we have in place in Chile. And they also solve main customer queries and complaints. So either it's from a loyalty program, financial services, value proposition, etc. So these tools, so to speak, in a more actionable way. Imagine that a customer that asks for a cheaper product, right? So they want to save money, part of our value proposition. Imagine a customer that needs help sorting through billions of SKUs to make a search more relevant. Imagine a customer that we can help by giving them relevant ideas with actionable recipes with the right quantities, with the right budget for the right occasion. Imagine a customer that has questions about issues like where is the pickup location. So all of this put in the hands of the customers. So let's go over quickly on the demo for Leader AI. And this is the homepage or the web page experience, right? So we're going to ask Leader AI about cooking a barbecue, right? So we click on it and we ask, I want to cook a barbecue, but I have some vegan friends coming over. I'm sorry that this is in Spanish, but it's the way that the experience is felt. So I have a vegan barbecue for people. I have no idea how to cook for vegan people. So basically, it's going to give me an idea of brochetas de vegetales. It's vegetable skewers. So it's going to go over whatever we want, whatever the customer wants in red peppers, mushrooms, tofu, olive oil, and it's going to give me how to cook this for the customers. And this is, and not only that, but the quantities as well, and right in the experience to the card that the customer wants, so they can purchase it directly. Now we're going to go over Carrito Listo. Carrito Listo is an agent trained to periodically, embedded in LIA, to periodically recommend shopping carts. But not only that, but also making sure that customers never run out of anything. So this is a part of that we want to highlight in terms of saving time. And this is basically the experience. This is now the app experience. So this is a mix of many models that are continually thinking about which mix of products do we share with the customer. What is the right basket for that day? When to push those notifications? Which is the day that you prefer to do your purchase? How many of each products, right? So the amount of yogurt that you actually use versus the amount of beef that you actually consume. So the seasonal offerings. So is this ice cream for summer? Is this chocolate milk for winter? And it's also learning from your customer feedback. So everything that you take back or every search that you do online. And of course, then you can, with one click, share the whole basket and purchase the whole basket. So, but then again, those are two examples, right? But let's go over the actual results. So they have shown a dramatic reduction in time spent in purchase, right? With high level of customer satisfaction. And this is 50% less time preparing a shopping cart. When you put that into perspective, this is not theory, right? This is actual impact on our customers. For example, for a basket of 30 items, we're going from 18 minutes to 9 minutes of saving time. That is, when you put it in a year's time, that's tens of hours that the customer is allowed to spend either shopping for more products with us, which is awesome, but at the same time, or choosing to spend time with their family or with their friends or doing something else, right? And that's also awesome for us and for them. So overall, a tool to help customers live better lives. This leads, of course, to extremely high level of customer satisfaction, and that to customer loyalty for sure. So why is Azure Cosmos DB has been an integral part, and how we have done this? So in the solutions, it has made it possible by storing metrics, location data, enabling real-time product searches. And as we saw, our customers' time is of the essence. Derek also mentioned that a lot, so I'm not going to go a lot over that. But they don't forgive latency. They don't forget poor memory, poor recall, right? They don't want to explain this over and over and over again. And that is where Azure has helped us as well. But it's also going to be an integral part of when we try to scale this, right? So if we scale it, now it's in Chile, but even if you scale it to other markets, or if we add new features. So orchestrating between this is part of what we're doing with Cosmos as a backbone, and potentially to scale. And then again, exactly why are these reasons? Low latency, it's key for a conversational agent such as Leader AI. For vector search and drag, millions of SKUs and billions of emotional content embeddings in our value proposition. So when you think about all the assortment that we have, going through that fast is an essential part. And then the last but not least is hyper-personalization. So Carrito Listo searches through for more than 4 years of purchasing history for that exact customer. So it has to run all those multiple models on that information, and that is something that is critical for our for an accurate recommendation. But I don't want to end up with this, right? Because we started with the importance of putting the strategy and the customer alongside. And I want to end up with the customer at the center. In an age of aging population, we have found that real impact comes from, especially from one of these more aging customers. And this is a quote from one of our customers that I found really impactful. So my daughter set up the app for me. I just open it and buy. Going to the shop is actually a stressful situation. So I'd only do it if I really, really, really need to. With Carrito Listo, it gets easier every time. This is Jacqueline, an 82-year-old customer from Santiago de Chile. And with that in the center, I would like to end the point, right? Putting strategy and the customer ensures that whatever we do with AI creates impact for basically the customer. Thank you. Thank you.
Thanks, Felipe. That's such a great example of the power of agentic applications to really make a difference in people's lives. And Carrito Listo just sounds really cool. Like, I hope you guys bring that over to the US. I'd love to give it a try. All right, so that pretty much wraps up our session for today. We have some resources for you to get started. We have documentation and resources on the Cosmos DB Learn documents for getting started with agentic memories. Of course, another link and QR code for the workshop that we talked about here. We have preview signups as well for some of the private preview features that we announced at Ignite in Cosmos DB. And of course, a couple more sessions today as well. There's a lab for multi-agent apps using Microsoft Agent Framework or LangGraph, and also BRK135, which is taking place at 1 o'clock, where we'll talk with Veeam about delivering planet-scale semantic search with Azure Cosmos DB on petabytes of data. So come talk with us at the Cosmos DB booth. Let's talk about your application and your agentic needs. Thanks, folks.